Okay, so picking up where we left off yesterday, we've got this idea of these two figures where one is enlarged or shrank down to create the other one, and the corresponding sides. That if you haven't watched that video from yesterday, if you haven't done the assignment from yesterday, do that first, then come back and do this. You have to be able to pick out these corresponding pieces and able to do this. So one thing that I purposely didn't talk about yesterday because I wanted to bring it up today, if you look at these triangles, right, it's pretty obvious. I took the ABC times 2 to get DEF. I literally doubled the side. If you set up the ratios of corresponding sides, so the ratios are fractions, corresponding sides means, one from the little one from the big one that match up or correspond, like we talked about yesterday. If I set up that fraction, let's say AB to DE, that fraction reduces down to 1/2. Okay, I'm not asking you to reduce fractions. I just want you to see something here. So BC and EF correspond. That reduces down to 1/2. AC and DF, that also reduces down to 1/2. Every single ratio of every pair of corresponding sides in similar triangles or figures, they don't have to be triangles, but that's what we're going to do, will always reduce down to the same given fraction. That is called the scale factor. Now, what that means, okay, and just kind of like big broad strokes here, that means that the first triangle is half as large as the second one. It goes both ways. If I had set those ratios up the other way, 20/10, right, 12/6, 14/7, those would have all reduced down to 2/1. That means that it's twice as big as the first one. It just kind of depends on your point of view. For the purpose of what we're doing, I always set these up starting with the smaller measurements, and I'll show you when we get into it. Okay, so what we're going to be able to do with this, we're going to set up a proportion. So from the other day, our proportions are two fractions that are equal to one another. And that gives us the groundwork to do the cross multiplication and the solving of our equations. So what I want you guys to do is to be able to set up a proportion to find BC, right? There's the question mark. So that's where I'm going to put my variable. When I set these up, I start building my proportion with the variable. So I know that that needs to be part of it. So I just set it up as my numerator, my first fraction, and I build everything around that. So BC corresponds with LK. So I know that I can set up X and 40 in a ratio. Okay, they correspond. They're going to get set up in a ratio. So I've used X, I've used the 40. Now, the 21 and 35 are going to be the other two pieces of the other ratio. I just have to make sure that I put the right number on top and on bottom, because if I do it backwards, I'm not solving equal proportions. So the way I do that, since I started with the X, right? This was the first piece I used. That's the first piece right there. My second ratio has to start from the same triangle. If I start with X, I have to start with 21 in my second ratio. Okay, make sure that you can go back and kind of follow what's happening there, and that I've set these up correctly. So when I cross multiply here, 35x, your equations aren't going to be big, tough ones to solve, but if you screw up that that second ratio, if you get it set up upside down, you don't have a chance. And then 840 for the second one. So when I divide that by 35, my x value winds up being 24. Okay, the similarity statement, the triangle statement here, that's going to be probably more helpful in my opinion than the actual triangles. Okay, I need that more than I need the pictures. So same thing, and it doesn't matter if you're setting up these ratios with bigger numbers on top. We're not actually really doing anything with the fractions at this point, so just kind of getting it set up is the important thing. So I'm going to do the same thing. I'm going to start with X when I build this. I know I'm setting up a proportion, so my scratch work here, X. Now X is MN, between M and N, so I'm going to match that up with the number between S and T. So X is going to match up with 12, right? I use that one. I use that one. They're not going to be used anymore. My second ratio is going to be 36 over 12. Now, if I were to give you all of the measurements, right, I'm only giving you the 4 you need. If I give you all of the measurements, you're going to have to kind of pay a little bit more attention to what's going on in the second ratio. So cross multiply here, 12x equals 12 times 36, 432. So when I divide, I'm going to get 36. Okay. All right, last one. This one, I threw this one in here because it takes your answer and then you have to do something with it. But the idea is basically the same. And don't freak out because these things are touching, right? That doesn't really add any sort of complexity to it since you've got the similarity statement up there. But I'm going to start out the same way. Go away. I'm going to start out the same way. I'm going to start with my x, right? So I'm going to start with this expression and I'm going to build everything else around that. So that is UC, right down here, UC. So that's going to match up with CE 112. So then my other ratio's got to be, I've got a choice of 80 over 50 or 50 over 80. So pay attention to which triangle you started with here. I started with the smaller triangle on bottom, so I have to start with the smaller triangle to build the other ratio. Now, this one's a little bit bigger number-wise. Remember, when you multiply here, this has to be treated as if it has parentheses in it so you can distribute. So what you're actually doing is taking 80 times 11x minus 7, and then over here 50 times 112. All right, so that's 880x minus 560 equals 5,600. Double check one of my numbers here. Yep. Okay. So just a little bit of algebra. Again, it's first day algebra here. Nothing too outrageous. So 880 x equals 5,600 plus 6160. Divide that by 880. I got 7. So all of that work to get 7 is your answer. Now, one thing I want you to be aware of, and if you zone in on this, pay attention to this right here. The x value is 7. That side is not 7. Okay? That whole side, I have to plug this x value back in. That's 11 times 7 minus 7. Grab a calculator. 11 times 7, 77 minus 7. This side is 70, even though the x value is 7. So this one actually has 2 answers, right? You're going to have to find the value for the x and then plug it back in and get the length of the side. Bye.